Hey everyone, and welcome back. Before you watch this walkthrough, make sure that you pause the video and try the problem yourself. Even a partial attempt will make the explanation that much more useful. These videos are meant to support your problem-solving process, not replace it. Across a lot of my practice problems, I highlight different aspects of how to approach, break down, and reason through problems. So you're going to get the best benefit by watching multiple walkthroughs rather than treating any single one of my videos as a template that you can copy. With that, let's get started. The problem statement says that we are searching a 2D array of characters for a target letter, and we'll be printing out the row and column indices once we find it. I'm going to add a little twist in here that also has it printing out target value not found if it doesn't exist anywhere in our array. Anytime that we need to inspect every element in our 2D array, your brain should immediately begin to think about nested loops. Let's get started with our comments. As usual, I've pre-made my main here, where I've gone ahead and created my 2D character array, as well as a character to be our target. I'll make it E to match the sample problem. We can print it out, which I'll do in a minute. I've created this FindInGrid function that will return an array of basically size 2, one index for the row, one index for the column. If my indices array is not null, I will say where I found my target value. If it comes back as null, that means I didn't find a target value, so I'm just going to print out target value not found. We can see that right now I have the FindInGrid method, but it doesn't actually do anything. If we go ahead and run this, I'll just save my code here, compile and run it. We'll see that we do get everything printing out as we'd expect with a target value not found message coming out, since of course FindInGrid is right now just returning null. So let's get our logic in here in comments. The very first thing that we need to do, since we're doing a find in a matrix, is that nested loop structure. We're going to loop through each row, and then we're going to loop through each column in the current row. Now, what's important for us to remember is we're looking for something. So if the current element in grid matches target, we need to do something. We've decided that we're going to store that information in an array. Store values of row and col indices in an array, and otherwise we're just going to keep looking. Then at the end, we can return null. Now, in our very small examples, this structure can continue looking even if we have found the value, and it would just update the indices. And basically, the way that I've written these comments would always find the last indexes of that target element. So if it appeared more than once, it would find the last index of it, like the last version. But we're not going to want that. We're going to instead do more of like a first index. Once we find it, we're going to want to bail out of our loops. So we're going to need to ask ourselves, how are we going to structure our loops for that to work? Well, I can't use for each loops because I can't get the indices of my row and my column for my for each loops. So I need some kind of for loop structure. But if I want to be able to bail out early and I want to follow the programming standards of this course, I can't use a break statement. So what makes the most sense is actually to use a while loop. So let's get a couple of variables in here. The first is going to be what we're using to keep track of our indices. Indices equals null. Now we can go ahead and add those row and column index counters, both of which should start at 0. Column index I, right, at 0. Now I said we're going to loop through each row. We can go while row at I is less than grid.length. So while we still have rows to go through, let's do it. Then we can loop through each column in the current row. So while our column at I is less than our grid row at I.length. A reminder from my previous video, we always want to be looking at the row we're on since it's possible for them to not be the same length. Then we're going to ask ourselves if the current value in our grid that we're looking at matches target. Chars are primitives. We can use our normal equals equality test. So we can just say if our grid at row I, col I is equal to target. There we go. What are we going to do? We're going to store those values in our indices array. So we can say indices equals a new int array, and we can just put right into it, row at I, column at I. So now we have both of our while loops created. We can't forget that we want to make sure that these are going through the whole while loop, which means incrementing each of these indices at the end of it. Normally our for loop takes care of that for us, but we don't want to forget that here. And before we make any changes to our program, we want to make sure that it is functionally correct at least. So let's give this a quick run. We'll compile it and we'll run it. And what we find is it currently actually isn't finding it. Now, we have to figure out why, and it's actually a very subtle reason that can be kind of tricky to find. But again, when we use while loops instead of for loops, we really have to remember that we are trying to get these to sort of function like for loops. And what we need to be doing is every single time our inner loop goes for a new row, it actually has to restart at column I equals 0. So I'm actually going to pick this up and move it internal, the whole declaration. You don't have to move the declaration and the assignment inside, but doing so more so mimics what my for loop would have done anyway. So let's go ahead and try to recompile and run this version. And now we can see we are indeed finding it at 1, 1. This is just my formatting issue, so I can go ahead and fix that right here. I did print F, but I should have just done a print line. There we go. And now we'll see we are finding it at position 1, 1. This is 0, 0. This is 0, 1. This is 1, 0. This is 1, 1. And we were indeed looking for E. Now, as of right now, I'm not getting any benefit to using while loops over for loops. But what I can do is I can add another condition here that says, and my indices array is still null. So while I still have values to look through and my indices array is still null, keep going. And I can add that check in both of these places, indices equals null. So now once this array actually gets set right here on line 33, and I come back up to the top of this while loop right here, it will break out because indices is no longer null. It'll go back up to the top of this while loop, and this will break out because indices is no longer null. And now, without even making extra Boolean variables or anything like that, I've solved my problem. Now, this could have been written with for loops with two conditions instead. For example, for int row I is equal to 0, row I is less than grid length, indices row I plus plus. So we could have done it like that instead. This is somewhat less standard. Typically, when we have multiple conditions, that we need to break out of our loop on, it makes more sense to do a while loop, but it wouldn't be wrong technically either. So like I can just show really quickly that this also is going to run. Whoops, I don't need the declaration twice now. I can just clear it, compile it, and run, and we'll see we'll get the exact same answer. And we'll see it also works if I go looking for a character like Z that doesn't exist. There we go, target value not found. The key takeaway here is really understanding how we control the traversal through our matrix using our nested loops, our Booleans, or in this case, using that impossible value of null here, and coordinating our tracking efforts through these nested loops. That's it, and now we've solved this problem. Now remember, you won't find my solution posted alongside this video. If you watch the walkthrough without first attempting the problem, stop here, close my solution, and try to write it yourself now. Post-walkthrough practice still counts. If you have questions about this problem or suggestions for future practice videos, please be sure to leave them in the comment section below. Thanks everyone, and I'll see you next time. Bye.